So in our factoring today, A is not 1. So we have to, you always have to pay attention to that because it operates differently when A is 1 versus when A is not 1. Okay? And this holds true even for -1 does not count as 1. Okay? So either you factor out a -1 first, if it's just a negative a squared or negative x squared, and then you can use the fact that now you have a trinomial where a is equal to 1 and you have another factor of -1. Okay, so when the quadratic trinomial does have an a value that is not 1, here's what we're going to do. Use our diamond method and factoring by grouping. So the first one here, we're just going to go right to work practicing because we're ready for this. 5x squared plus 11x plus 2. Just like we did yesterday, the first thing we're always going to do is identify our a, b, and our c. So what's our a? 5. What's our b? What is it? 11. I thought I heard 4. And c is? 2. Okay. Here's what's different in our diamond method today, though. You know, yesterday when we were doing this, a was equal to 1, so we didn't, in reality, we could still say that we have to take a times c, but what would be 1 times c? Still be c, wouldn't it? So when a was equal to 1, we didn't have to worry about taking the a times the c, but today we do. So if you just get in the habit of always taking a times c, it's not a big deal, okay? But, and then our b is still down here. So we're still going to use the same process though. After we take a times c, so what do we have? We have 5 times 2. Let's just be really complete in our notes here. We have 5 times 2. And our b value is 11. So we have to get numbers that will multiply to be 10 that will add up to 11. No different than yesterday, but we just have to make sure that we get that top value right, okay? So what do we have? 10 and 1. Now here's what's different from yesterday. Yesterday we would go right to setting up our factors. Today we're not. We can't yet. Okay? Here's what the 10 and 1 are going to do. They are actually going to become x's. They're going to become x's now. Okay? So we're going to break our, what we're going to do is we're going to take this 11x that's up here, and it's going to get replaced with 10x plus 1x, because that is the same as 11x. So we're going to make our trinomial into a 4-term polynomial, and then we can use factoring by grouping. Okay? So we are going to write it as, we're just going to rewrite it as 5x squared plus 10x plus 1x. So notice this is where this is replacing our 11x plus our 2. And we're going to factor it by grouping. We have a 4-term polynomial now. We don't have any subtraction, so we can go right to setting up our groups. So let's those first 2 be a group, and the last 2 be a group. And then take care of each group independent of each other for a bit here. What's the GCF of the first group? 5x. The resulting factor for that one, after you divide each of those terms by 5x, what do we have?
X plus 2.
X plus 2. 5x squared divided by 5x is x. 10x divided by 5x is 2. That takes care of that group. Now our second group. What's the GCF of 1x plus 2? 1. So we have x plus 2. Because remember, what was our goal when we were factoring by grouping? We don't move on unless what?
There's an addition.
No, there's addition. Those binomials that we have right here are the same. Are these exactly the same? Yes. If they're exactly the same, now they're back working together. Now this is, we're saying, okay, they still were always a part of the same polynomial, but we're letting them work back together now. Now we're saying, oh, those 2 terms, we actually have 2 terms here. Here's one, and here's the other. Those 2 terms have the same GCF, the same factor in common, I mean, so that's their GCF, x plus 2. And the resulting factor, no addition here, the resulting factor is, after I take this first term and divide out that x plus 2, what do I have? 5x. Now, this is where that addition sign comes. It comes down here. Because now I'm going to GCF that 5x, or that x plus 2 out of the 1 times x plus 2. What do I have? 1. So we are saying that the factored name for our original trinomial is x plus 2 times 5x plus 1. Would you multiply that out, please? FOIL, rectangle, your method, horizontal, vertical, whatever. Actually FOIL it out, multiply it out. And of course, the goal is to come back to, I know we always started with 5x squared plus 11x plus 2. And because it actually does multiply out, not because that's what we want it to become. Right? Because if it doesn't, check out what you should do. Go back, you gotta do it again, try it again, you gotta learn how to do it. Okay? So, a pretty slick way of getting there without having to try a whole bunch of combinations. Do you agree? Yeah? Okay. Anybody got a question? Yeah, let's go to the back side and see if we grab a couple more we're going to practice and then you can go work on your homework. Okay, what's the first thing we always want to make sure we do? Add the opposite. Unless you can make sure you identify A, B, and C correctly without changing it to add the opposite. If you tend not to do that part right, then you better do the add the opposite. So our A is B, negative 14, and C is 6. Okay. What are we going to do up here? We're going to take 4 times 6. What goes down here? Negative 14. Okay. So that's all we're going to do in that x, just to show ourselves in our notes what we had to do. 4 times 6 is 24. And so we have to have factors of 24, 2 factors of 24 that add up to negative 14. Negative 12 and negative 2. Negative 12 times negative 2 is positive 24, and negative 12 plus negative 2 is negative 14. Okay, now what do we do now? What's next? What do those become? Those become x's, this right here. These actually become negative 12x plus negative 2x. That's what that becomes. It doesn't, we're not ready to set up our factors yet. And now we're going to rewrite our trinomial, replacing what? What are we going to replace? The negative 14x. Yeah, this right here has to get replaced with our, what we just have there. So we have 4x squared plus negative 12x plus negative 2x plus our 6. And now we're ready to factor by grouping. Okay, go ahead and factor that by grouping. Put your practice back in and factoring by grouping on your own. See if you can do it. What happens if you use positive 2 as your GCF for the second group? What happens? Yeah, those two terms of that binomial don't match, do they? They're the opposites of each other. So what do? What do we say we do when that happens? We, instead of factoring out the positive, we factor out its opposite, the negative. So negative 2, make your second group's GCF negative 2 so that you can have matching binomial factors. And then you can say, okay, the greatest common factor of those, that is our x plus negative 3, and makes the other factor 4x plus negative 2. I'm going to clean that up, show how it would actually be shown in an answer bank. And now you can do your check problem and see if we're right. If you agree with me, or if you got a different answer, you check yours at the end. See who's right. I'm feeling pretty good about my doctors. Do you agree with me? Yeah? Okay, you try that number 3 one, all on your own. Begin again. Yeah. So you can do it. Anybody have any questions they want to ask though? Something that's tripping you up? Not quite getting here? After you're done with the diamond method and grading your 4-term polynomial, you want to check to see if you agree with me. I think I'm right. I can be challenged though, of course. Okay, so feel free. count on you to do the check problem. And then you've done the check problem, you'll be able to verify for me whether I'm right. Anybody agree with my answer? Yeah, okay, you checked it? Make sure we're right? Okay, awesome. Questions? How many of you agree that this is a lot slicker than having to just try all other combinations? Those of you who did SQ3R, lesson 7.4, you don't have to know what we're talking about right now. But what the book does is it has you just setting up a table and trying different things and seeing which one works. And it can be quite a process. It can take you a while. So when we do it this way, it just so nicely leaves us right there. But if we don't have a good understanding of factoring by grouping, that might be where it's going to give you the challenge. So then if you say, I don't like that factoring by grouping, then you study the book and you under their way. Okay?